Now let's talk about circles. The circumference is the perimeter of a circle. So think about the distance around the circle, the path that you're walking around a circle, or think about a pizza and the crust of a pizza. And if we don't walk the entire circumference, or if we don't eat the entire pizza crust, then we have a portion of that circumference only, and that is what we call an arc length. Remember, we already talked about arcs, and arc is a portion of the circumference. So I want you to think of the part of a circumference, maybe a curved fence around a garden when you're only fencing in part of that garden. The sector of a circle is the region bounded by two radii of a circle and their intercepted arc. That sounds complicated, but what I want you to think about is a pizza slice. A slice of pizza, or even a slice of a pie. And here are some examples. Find the area of the sector that is shaded. For the area of a circle, we use that formula down here. The area is equal to pi r squared. That means we need to know what the radius is. Looking at our picture, we see that we are given the radius, and the radius is 3 feet. But then we are only supposed to find part of the area, not the entire circle, just the sector that is shaded. And we are shown that the sector that is shaded covers an angle of 70 degrees. Now remember that around our entire circle, that is 360 degrees. And now we have a portion which is 70 degrees. So we only want 70 out of the 360. So now we're ready to write down our formula. The area of the whole circle would be pi times 3 squared. But that we want to multiply by 70 over 360, because that's the part that our sector covers from the entire circle. And punching that into your calculator, you're going to get approximately 5.5, and since it's an area, this is feet squared. In our next example, the area of the shaded sector is 49.1 square centimeters, and we're supposed to find the area of the entire circle. Now we're going backwards. We are given the area of our sector, but we need to figure out the area of the entire circle. First, we need to find out what angle is covered by our sector, and we can do that by taking the 360 degrees and subtracting the 135, which are not shaded, and that leaves us with 225 degrees, and that is the angle covered by the shaded sector. And that shaded sector has an area of 49.1. Now that we need to multiply by 360 because we want the entire circle over 225. Put that into your calculator and you're going to get approximately 78.6. And again, this is squared. What units did we have? Centimeters. And we're keeping the squared centimeters because we're still talking about an area. Find the arc length of AB. Remember, the arc length is part of the circumference, and here we're supposed to find the arc length not just in degrees, but since we're given a radius with feet, we have to find the arc length in the same unit. For our circumference, the formula sheet has two formulas that we can use depending on whether we're given the radius or the diameter of that circle. In this example, we are given the radius, so we're going to use the formula circumference is equal to 2 pi r, and that will give us the entire circumference. And similarly to the previous examples with the sectors, we only want a section of that, and the section of that is proportional to the angle that it covers. In our example, we are shown that the central angle is 135 degrees. That means that the intercepted arc is also 135 degrees, and that is 135 degrees out of the total of 360. So let's plug in our numbers. The circumference of the circle is 2 pi times 6, which is our radius. And then for the arc, that's 135 over 360. Put that into your calculator, and again, you get an approximation, which is always going to be the case if you're using pi. And in this case, it's approximately 14.1. The unit is feet, and we're talking about circumference, so we're using the unit just like that, and here's our answer. And in our last example, we're going to go backwards again, find the circumference of the circle D when we are given an arc length, the length of the arc xy with 4.19 inches. Our central angle measures 40 degrees. That means that our intercepted arc also measures 40 degrees, 40 out of 360. So the arc measuring 4.19 inches will give us the entire circumference if we multiply it by 360 and divide by 40, and that is approximately 37.7 inches. All right, so much for this, and I will see you in class.